Hi, my name is Omer Gvirsman. I'm a PhD student at the Curiosity Lab at Tel Aviv University. And today I'd like to share with you our work on creating Patricc, a robot for interaction with toddlers. In this talk, I'm going to focus on the design and the initial evaluation of the system. Before we go into the design, I'd like to give a little bit of background. Most of you are probably aware that there are a lot of studies in social robots in education. Most of these studies address ages that are 5 and above, and the mode of interaction is usually one-on-one, a child and a robot, or a child and a group, robot and a group of children. And in many times, they involve screens where the child and the robot play together on a tablet or a computer. Now, you can't just take robots and interactions that are designed for older children and use them with toddlers, because toddlers have special considerations. Toddlers explore the world more physically. They have shorter attention spans. At their young age, they still don't have the preconception of the traditional robot design. And two more important aspects are that they need more emotional support and more social interaction. That's why at the beginning of the project, we decided that Patricc will accommodate for the special characteristics of toddlers, but that the emotional support and social interaction will be provided by the caregiver that will also be part of the interaction. So our goal was to design a robotic system for long-term triadic interaction, which means that we want not only the child, we want both the child and the caregiver to have motivation to continue engaging with the robot over time. The special characteristics of toddlers, we use them to derive our design goals. So short attention span led us to decide that we want continued novelty in the system, not only in the interactions, but also in the physical features of the robot. Because toddlers explore their environment physically, we wanted the interaction with the robot to be as physical as possible. Because they still don't have the preconception of the traditional robot, we decided to design Patricc as in the familiar puppet design that children love. And because we have the supporting caregiver, we understood that we need to address the caregiver in the design of the triadic interactions. One more design goal that we have that is low cost, and it's not connected to toddlers. It's because we want a large scale of experiments, so we need the manufacturing costs to be low. The main components of Patricc are a robot, a console that is used for the interaction, and an authoring tool that we created for designing new interactions for Patricc. The main features of the robot are changing characters. You can change the exterior puppet that the robot is wearing, so we have very diverse interactions. The robot has rich expression capabilities with 8 degrees of freedom. It can point and gaze accurately and has a wide range of gestures. And it has a plush exterior that children just love to hug and touch during the interactions. The console is the base for the robot, and it also has the sensors. It has five RFID sensors within it, one behind every white plate. And these sensors can detect the props that have RFID tags connected to them. So it's very easy to add new props. You just have to stick on an RFID tag to any object that you want, and you have a lot more. It's easy to accommodate for new content. The authoring tool was designed for non-programs. We wanted to enable teachers that might not have experience in coding to create their own interactions. In this way, we can have a large amount of interactions and also high-quality interactions. To create new interactions, it's very easy. You record your voice through a microphone and record your emotions with a Connect sensor. This creates a behavioral block. And then with a simple text interface, you orchestrate the behavioral blocks to create an interaction flow. In our first study, we had 2 goals. One was to evaluate the physical design features of Patricc, and the second was to learn about the triadic interaction. The context of the experiment was learning a second language, and we had parents and 18 couples of parent and child come to the lab and play together with robots. Each parent and child had 3 sessions with the same robot, and between sessions we changed the puppet to a different character. In each session, the robot sang a song teaching about 5 words, and then the robot played with the child a game where the child had to pick up and put down different props on the console. In the experiment, we had 2 independent variables. One was the platform. In one of the sessions, the parent and child didn't interact with the real robot, they interacted with the tablet, an app created for the experiment. In the app, the parent and child saw the robot, and instead of picking up and putting down the real objects, they had to tap on the objects on the screen. The second independent variable was the order. We compared the interaction between the first robot session and the second robot session. We video coded all the interactions, and from that we measured the amount of gaze that the child and the parent, how much the child and the parent gazed towards each other and toward the tablet or the robot, and this was a measure for engagement. After all the sessions, each parent was interviewed for about 20 minutes with an anthropologist about his experience. So the results. From the video coding, we learned two things. One was that during the tablet interactions, the parent and child mutually gazed at the tablet more than they mutually gazed at the robot in the robot interactions. Actually, practically during the tablet interactions, the parent and child looked at the tablet almost all the time. The second finding was that during the robot interactions, the parent gazed more towards the child than the amount the parent gazed toward the child when they were interacting with the tablet. And this for us is an indicator that the robot promoted more engagement between the child and the parent compared to interacting with the tablet. From the interviews, we learned that 56% found the robot better for teaching language. These parents commented on the physical aspects of the robot. One of them said that it activates more senses than hearing and seeing. 50% of the parents saw the experience as a joint parent-child activity. Out of these parents that saw it as a joint activity, one of them said, at these ages, toddlers need mediation, especially if it is something new that will take a while for a toddler to connect to. 67% thought that changing characters contributed to the experience. One of the parents said, he reacted differently to each character. He thought the strawberry was cuter than the bird. And I see this as an opportunity to use the changing characters to personalize the experience for each child. The downside was that 39% thought that the activities were too long and repetitive. So if I sum everything up, we have initial positive indication of the value of Patrick's physical features, the physical interaction, the plush design, the changing characters. But on the non-physical aspects, we need to improve the interactions that were too long and need more variation. Currently, we're working on creating more interactions and more diverse interactions with the goal of performing a long-term experiment in the wild in families' homes. And we're planning another study to evaluate the authoring tool, where we're going to give the authoring tool to teachers and see how they can create interactions of their own. So that's about it. Thank you for watching this talk. If you have any questions or thoughts, please contact me by email. I'll be happy to talk to you. And I hope you are well, and I hope next year we'll meet in the physical conference.
See you soon.